Okay, so worksheet 6. We are going to be using the Pythagorean theorem to find missing sides. So let's do number 1 together. So now we know that that all of our triangles are right triangles, so you can assume that. But we're going to give you either 2 legs or a leg in the hypotenuse, and you have to find the other side. So let's do number 1 together. I'm going to white out my space so I have extra room. So number 1, I have 8 and 15. Are those 2 legs or are those a leg and a hypotenuse? 2 legs. It's just turned on its side. Remember, the hypotenuse is the one diagonal from the right angle. So this is 2 legs. So what we're going to do is we're going to plug in 8 squared plus 15 squared equals c squared. And we're just going to solve for c. So what is 8 squared? 64. What is 15 squared? 225 equals c squared. Maybe we should have a contest to see who can memorize the most perfect squares. Okay, not right now. What's 64 plus 225? What'd you get? 289? Did anybody else get 289? Okay, so I'm going to go on your word. 289 equals c squared. Okay, I see a problem here. Maybe you guys can help me out. Hold on, let me black out a little bit more. 289 equals c squared. How do I get rid of that square? What's the opposite? So let me think about this. Subtraction is the opposite of addition. Division is the opposite of multiplication. What's the opposite of a square? Square root, which is why we did square roots on the very first day of school. Oh my gosh. So what you're going to do is you're going to take the square root of both sides.
Some of them don't have square roots.
17.
Good observation. Not all of them are going to come out to perfect squares. Is 289 a perfect square?
Yes.
Yes, so we end up with c equals what?
17.
17. Box it so I know that's your answer.
Yeah, and 4 squared equals 12.
Okay, so number 7. We have a leg of 4 square root 3 and a hypotenuse of 8. So which side do you want to call this? Do you want this one to be A or B? A? Let's call it A. It doesn't really matter. Okay, so this is going to be a squared plus, put it in parentheses, 4 square root 3 squared equals 8 squared. So let's do all the squares first. A squared we can't do, so that's a squared. Now, 4 root 3 squared. How do we do that? We're going to do this all the way through first, and then I'll show you the shortcut. What does 4 square root 3 to the second power mean? What does it mean? Here, let me help you guys out. It means 4 square root 3 times what? Times 4 square root 3. It's not times 2. Squared means you're multiplying it by itself, right? Okay, so when you are multiplying square roots up here, it's like multiplying like terms. We multiply the like things. So we multiply 4 times 4 first. What does that give you? 16. And then inside the square root, we multiply 3 times 3. What does that give you? 9. Okay, can you take the square root of 9? Yes, so this is going to be the same as 16 times, what's the square root of 9? 3. Which comes out to what? What's 16 times 3?
48.
6 times 3 gives me 18, carry the 1, 48. Yep. Okay. How could we shortcut this? 4 squared gives me 16. Square root 3 squared, they undo each other, which gives you the 3. Okay, so a square root and a square undo each other. Or you can write, I would like you to write it all out at first until you get comfortable doing it in your head. So this is going to be a squared plus 48 equals what? 64. And then how do we get a squared by itself?
Inverse operations.
Inverse operations, which means I'm going to what? Subtract 48 from both sides. So that gives me a squared equals what? 64 minus 48 is? 15? 16. Whoa. Let's try it again. 16. Okay. And then how do we get a by itself, everybody? Square root. So square root both sides. The square root of a squared is a. And the square root of 16 is 4. So your missing side is 4.
How do you do the shortcut?
All right, so number 16, last one. One of our legs is root 3, and one of our legs is square root 5. So let's plug those in. Make sure you put them in parentheses. So this is going to be the square root of 3 squared plus the square root of 5 squared equals c squared. Okay, guys, the square root of 3 squared. Square root of 3 times square root of 3 gives me square root of 9 plus the square root of what? Good, the square root of 25. So the square root of 5 times the square root of 5 equals c squared. What's the square root of 9? 3. Plus, what's the square root of 25? Okay, equals c squared. Really quick, let me bring your attention to something. What do you guys notice? If I have the square root of 3 squared, what did I actually end up with? 3. If I have the square root of 5 squared, what did I actually end up with? So what happens? It stays the same. The square root and the square actually cancel each other out. And you end up with just what's on the inside. So you don't have to do this middle step anymore. It will always turn out to just what's on the inside. Okay, so then let's finish this up. What is 3 plus 5? 8. So 8 equals c squared. Do I have c by itself yet? No. So let's take the square root of both sides. And that leaves me with c equals the square root of 8. Can I take the square root of 8? No. But are there any pairs inside of 8? How could you break 8 down? 4 and 2. And how would 4 break down? 2 and 2. So make sure you're writing this. So how many 2's are actually inside of 8? 1, 2, 3. We can pull one of the pairs of 2 out. So circle one pair of 2 and pull it out. So that's actually going to leave me with c equals 2. Oops. Let me write it to the other side. C equals 2. And then that other 2 stays inside the square root because we couldn't pull them out. So it's going to be 2 square root 2. And that's your answer.